Welcome to The Explainer. Today, we're going to decode the absolutely monumental weather system that is the Indian monsoon, and we're going to do it by breaking down the foundational blocks of climatology. You know, for those of you preparing for competitive exams, especially the UPSC, you already know that getting a grip on these specific climate mechanics is absolutely essential. I mean, mastering this single topic literally unlocks a huge chunk of your climatology syllabus. So we're not just going to sit here and memorize facts today. We're going to really understand the intricate, high-altitude physics that drive one of the most powerful, fascinating weather phenomenon on the entire planet. Let's get into it.
All right, here's our roadmap for today. First, we'll start with decoding India's climate, then we'll move into the ITCZ and jet streams. After that, we'll cover the monsoon mechanism explained, and finally, we'll wrap up with India's annual weather cycle.
Okay, Section 1. Decoding India's climate.
So let's start by clearing up a classic preliminary exam trap, right? The difference between weather and climate. Weather is just what you see when you look outside your window today. It's short term. Climate, on the other hand, is the grand, long-term average, usually measured over 30 years or more. So when we say India has a monsoon-type climate, we're actually talking about a massive, regional, long-term pattern that completely dictates life across the subcontinent.
India's highly unique physical geography basically sets the perfect stage for this dramatic climate. We're really looking at three massive factors here. First, there's the vast coastline. This allows for rapid heating and cooling differences between the land and the sea, which is the exact mechanism that causes seasonal wind reversal. Second, you have the mighty Himalayas. They act like this impenetrable giant shield against freezing Siberian winter winds. And finally, the Tropic of Cancer slices right through the middle of the country, giving us both tropical and temperate zones. It's a pretty wild setup.
Moving on to Section 2, ITCZ and jet streams.
Now, to really grasp high-level climatology, you first have to understand these rapid, high-altitude rivers of air. Jet streams are these incredibly fast-moving winds situated way up high in the atmosphere. They meander around in these narrow, winding paths that can literally stretch for thousands of kilometers. I like to think of them as the invisible conveyor belts that steer our global weather systems. And here are the heavy hitters that power our monsoon engine. By the way, this is a highly testable concept for your exams, so pay attention here. First, you have the subtropical westerly jet stream. This one is permanent, but it physically shifts north of the Himalayas to actually allow the monsoon to enter. Then we have the temporary summer players. There's the tropical easterly jet firing up high in the atmosphere, and the Somali jet, which is a lower-level stream over near the Horn of Africa that pushes winds directly toward India. Now, besides jet streams, we have the seasonal shifting of the ITCZ, or the Intertropical Convergence Zone. This acts like a massive magnet pulling winds across the equator. The ITCZ is basically a low-pressure convergence zone where northern and southern trade winds literally crash together. And because it tracks the sun's movement, it shifts northwards during the Indian summer. When it does that, it drags all that intense, stormy energy right over the subcontinent.
So this brings us to a fascinating geographical mystery. What exactly triggers the explosive burst of the Indian monsoon? Well, it's not just one single thing. It's actually this incredible sequence of high-altitude dominoes that all have to fall at exactly the right time. Let's break those dominoes down in Section 3, the monsoon mechanism explained.
Okay, this sequence is tested all the time, so let's walk through it step by step. During the summer, the Tibetan Plateau just bakes in the sun, creating an area of intense, localized low pressure. This hot, light air rapidly rises all the way up into the tropopause, travels south, and then sinks near Madagascar, creating what's known as the Mascarene High. This high-pressure area then violently hurls moisture-laden winds right back toward India, and it gets a huge assist from that tropical easterly jet stream we talked about. It is literally an enormous, self-sustaining atmospheric loop. But wait, simultaneously, that permanent westerly jet stream, it has to get out of the way. It physically shifts north of the Himalayas, drastically dropping the atmospheric pressure over India to attract the incoming rain. Remember, as long as that westerly jet stream sits over northern India, its high pressure suppresses the rain. So its physical migration to the north is the exact geographical marker telling us, hey, the monsoon is about to burst. We also have to factor in some localized terrain tricks. Take the extreme funneling effect at Monsoon, for example, which causes world record rainfall because the terrain just traps the winds. But if you zoom out, you have these massive global disruptors, and these are absolute favorites for UPSC examiners. You've got the Indian Ocean Dipole, which can either supercharge or totally kill our rainfall depending on pressure variations, and of course El Niño. warming waters way over by Peru create a global high-pressure ripple effect that can severely weaken our entire monsoon engine.
All right, let's tie all of this to what we actually experience on the ground in Section 4, India's annual weather cycle. So consider this your ultimate climatology cheat sheet. It beautifully captures the complex interplay of everything we've just been decoding. You can trace how the low-pressure troughs attract the trade winds, how the easterly jet stream shifts things north, and how the retreating winter disturbances loop right back in. It's like a giant puzzle coming together. This timeline lays out the progression of the year perfectly. India's climate is so much more complex than just summer and winter. We go through these incredibly intense transitional phases. The extreme heating from March to May gives way to the sudden, explosive burst of the southwest monsoon in June. Then, as the ITZ shifts back down in October, we experience that sweltering, infamous October heat before winter finally manages to set in. Now, before the main monsoon even arrives, that intense summer heating triggers localized storms. And heads up, matching these storms to their regions is a classic exam question. Down south in Kerala and Karnataka, you have mango and blossom showers, which are great for ripening early crops. Over in the east, Bengal and Assam get hit by violent thunderstorms known as Kal Baisakhi. Scary, but actually great for jute and rice. And up in the north, oh man, the Lu, just scorching, incredibly dry winds that completely bake the plains. So as those southeast trade winds are finally pulled across the equator, the Earth's rotation, specifically the Coriolis force, kicks in and physically bends them to the right. That's how they become the southwest monsoon. Once they hit the southern tip of India, they actually split. The Arabian Sea branch hammers the western Ghats, while the Bay of Bengal branch sweeps all the way out toward the northeast. Then, as the year starts closing out in the monsoon retreats, the skies clear up but the temperatures suddenly spike. That's your October heat. This retreating air breeds massive cyclonic depressions on the eastern coast. Meanwhile, right in the middle of winter, that permanent westerly jet stream sweeps down from the Mediterranean Sea, carrying vital winter rain all the way into northwest India. And let me tell you, that rain is absolutely critical for the winter wheat crops. Looking at all these moving parts really leaves us wondering just how fragile this magnificent, finely tuned climate engine might actually be, especially as the world around it rapidly changes. We've seen how perfectly synchronized the heating of the Tibetan Plateau, the massive jet streams, and the ocean pressures literally have to be. With global temperatures actively shifting right now, this incredibly complex system is being pushed into unknown territory. What does that mean for the future of the monsoon? Well, that's something we'll all be watching closely. Thank you so much for joining me on this explainer. Keep your notes handy for your revisions, stay curious, and I'll catch you on the next deep dive.